Top 10 invisible tech gadgets. You use them but don't see them. You wake up, tap your phone, and the coffee's already brewing. The lights dim to your favorite scene. Fitness app congratulates you for a good night's sleep. You stroll out the door and traffic reroutes to shave 10 minutes off your commute. You didn't notice any single gadget doing all that, and that's the point. The most powerful tech of our era isn't always flashy hardware with LEDs and logos. It's tiny, embedded, distributed, and invisible. Sensors in the walls, chips in fabrics, microcontrollers in streetlights, AI at the network edge. These devices quietly sense, decide, and act, making modern life feel seamless. Today, we're counting down the top 10 invisible tech gadgets you almost certainly interact with every day but rarely see. For each one, I'll explain what it does, why it matters, and a few real-world examples. Smart dust and distributed microsensors. Think of smart dust as thousands of microscopic sensors sprinkled across an environment, on bridges, in fields, inside walls. Each node measures simple things: vibration, temperature, humidity, or chemical traces. Individually, they're tiny and limited. Together, they form a dense, real-time sensory fabric. Why it's powerful: dense, cheap sensing at scale. Smart dust enables structural health monitoring, bridges that warn before cracks spread, precision agriculture, soil moisture maps at meter resolution, and industrial predictive maintenance, motors that report bearing wear long before failure. Because each sensor is small and low power, networks can be left in place for years. Real-world example: agricultural farms deploying networks of soil sensors to reduce water use by 40 to 60%. Infrastructure pilots use vibration sensor grids to detect microfractures in bridges. Why you don't see it? Nodes are tiny, enclosed, often buried or bonded to structures. The intelligence is in the cloud and analytics dashboards. The sensors themselves disappear into the background. Edge AI modules and cameras and appliances. The camera in your doorbell or the chip inside your smart fridge isn't just sending video to the cloud. Increasingly, tiny AI accelerators on device at the network edge analyze streams locally, detecting a package at your doorstep, classifying spoilage in the fridge, or flagging abnormal behavior in an elder care setting. Why it's powerful: reduced latency, lower bandwidth, and better privacy. Edge AI can operate without a constant cloud link, preserving privacy. Faces are identified on device, not uploaded, and reacting instantly. Stop a runaway robot or trigger an alarm. Real-world example: doorbell cameras that can distinguish family members from strangers using models running on a 2 to 5 watt processor. Factory cameras that detect defects at production line speed without sending terabytes of footage upstream. Why you don't see it: edge modules are integrated into existing devices, a little chip on a board, doing heavy lifting while remaining physically invisible. Smart fabrics and wearable electronics. Your clothes are becoming computers. Threads woven with conductive fibers, temperature sensors, and actuators can measure heart rate, posture, or even deliver haptic feedback. This isn't bulky wearables, it's textiles that behave like devices. Why it's powerful, comfortable, continuous health monitoring, and new interaction modes. Athletes get real-time biometric coaching. Physical therapy patients get posture correction cues embedded into shirts. Concert goers feel music via haptic jackets. Real-world example: smart shirts that monitor ECG signals for arrhythmia detection, or smart socks that provide gait analysis for runners to avoid injury. Why you don't see it: the sensors are threads and fibers, machine washable, thin, and integrated into garments so they feel like clothes, not hardware. Embedded sensors in buildings. The living infrastructure. Modern buildings are instrumented. Pressure sensors in HVAC ducts, occupancy sensors in rooms, strain gauges in load-bearing beams, moisture sensors behind drywall. Collectively, these sensors turn a structure into a living environment that optimizes energy use, improves safety, and lowers maintenance costs. Why it's powerful: buildings that adapt to human presence and the environment. Lights and HVAC respond to occupancy and CO2 levels. Leak sensors find problems before mold forms. Elevators adapt to rush hour flows. Real-world example: smart office buildings that cut energy use by 30% through occupancy-based heating and ventilation. Moisture sensors that stop outbreaks of structural rot by catching early leaks. Why you don't see it: sensors are enclosed in HVAC ducts, ceilings, and walls. Control decisions happen in building management systems. Dashboards you rarely open. IoT and transportation, invisible hands on the wheel. Modern transport relies on embedded devices everywhere. Fleet telematics, SIM-enabled traffic lights, roadbed sensors that report load and temperature, and V2X modules that let cars talk to infrastructure. Why it's powerful? Safer, more efficient mobility. Cities can optimize signal timing in real time. Trucks plan routes to avoid congestion and save fuel. Vehicles coordinate to smooth traffic waves. Real-world example: adaptive traffic lights that shorten commute times by changing phasing based on real-time vehicle counts. Logistics companies cutting fuel costs via predictive routing. Why you don't see it? Sensors are in asphalt, poles, and vehicles. Systems orchestrate traffic behind the scenes while you enjoy a smoother ride. Environmental and health biosensors. Hidden biosensors are everywhere. Air quality nodes on streetlights, wearable glucose patches, and disposable test strips that sync with your phone. They quietly track pollutants, pathogens, and biomarkers that shape public health and personal wellness. Why it's powerful? Real-time data enables faster responses and personalized medicine. Imagine pollen sensors warning allergy sufferers or pathogen detectors, spotting outbreaks before they spread. Real-world example: low-cost air sensors mapping pollution block by block, adhesive patches tracking glucose or hydration for athletes and diabetics. Why you don't see it? The sensors are tiny and discreet, stuck to skin, poles, or inside devices. You only see their data, not the hardware itself. Invisible authentication. Behavioral and biometric sensors. Passwords are fading. Now your phone identifies you by how you type, walk, or hold it. These subtle patterns act as silent ID signals. Why it's powerful? It keeps you secure without friction. Systems can spot imposters instantly when behavior shifts. No PINs or passwords needed. Real-world example: banking apps that verify your identity through typing rhythm. Phones that stay unlocked only while sensing your gait or voice. Why you don't see it? The sensors already live inside your phone and laptop, working quietly in the background. Micro-actuators. Small movers with big impact. Invisible tech also moves the world. Micro-actuators are tiny motors and valves that steer airflow, deliver medicine, or adjust surfaces on command. Why it's powerful? Precision control with almost no energy. Think of smart inhalers releasing exact doses or windows that tint automatically without blinds. Real-world example: self-adjusting glass that cools buildings, implants that release medicine in time bursts. Why you don't see it? They're built inside walls, pipes, and products. You only notice the effects, never the machines themselves. Edge gateways and invisible networks. Behind every smart device is an unseen orchestrator. Edge gateways that collect sensor data, run AI locally, and decide what to send to the cloud. Why it's powerful? Decisions happen instantly and privately, reducing bandwidth and latency. Real-world example: stores using edge systems to heat map customers in real time. Hospitals spotting anomalies before alerts reach central servers. Why you don't see it? These gateways hide under counters and ceilings, the quiet routers running your connected world. The invisible AI running everything in the background. The most invisible tech of all isn't a gadget. It's the AI code connecting everything. Whether in a thermostat, a city grid, or a supply chain, these models learn, predict, and act without you realizing. Why it's powerful? They remove complexity, turning sensor data into intelligent decisions. Real-world example: smart grids that rebalance power after storms, assistants that reorder supplies before you run out. Why it's invisible? AI lives in software and silicon, unseen but everywhere, shaping the physical world in silence. Welcome to the invisible age. Technology is disappearing from sight, blending into our homes, our cities, and even our clothes. It's making life smoother, smarter, and more connected than ever before. But as it fades from view, new questions rise. Who controls your data? Who audits the AI making decisions for you? And how much of the world around you is already automated without you realizing it? Remember, invisibility is power, but only when it's transparent. If this deep dive into hidden tech blew your mind, make sure to hit that like button, drop a comment telling me which invisible gadget surprised you the most, and subscribe for more weekly explorations into the tech that's quietly reshaping our world. Because the most powerful technologies aren't the ones you see, they're the ones working silently behind the scenes.